So this is how to make a region negated. There is no way to do this in the graphics class, which is the way you might want to do it. That doesn't exist. So I have this thing here, and we have an image, and it's going to negate what we select to. So if we select all, it'll negate the whole thing. Circle, it'll make a circle. Half, will negate half of it, and then revert, will put it back to normal. So if you're wondering how I did this, you can see here, and if you're wondering how this works, this is just an embedded resource right here. You can see. And you can see when I click one of these buttons, this one just draws over it, but see if I click here, it creates a region, and it's going to cover the whole image, and it's going to call our negate region method with the image and the region we made. And then it's going to invalidate the picture box so it shows the resulting image. And you can see this one is similar. This one creates a graphics path and makes a region with an arc with this rectangle. This should probably be an ellipse actually. Let's make an ellipse. That'll work better. And I don't think I should need this, but I'm just gonna keep it there anyway. Then this makes half of it, half the height, and so it's all going to call this negate region method, which I've set up here. So it takes a bitmap and a region. So the way this is gonna work is first we need to get our bitmap data. This is basically a more performant way to access the bitmap data than using get and set pixel, because those are extremely slow, and this would take like this could take like a full 20 seconds if you actually used the set and get pixel, because they all use this, and this is a more performant way to do it. It's going to be using pointers. So okay, that made no sense. What I was trying to say is that get and set pixel use the lock data in their definitions, and calling lock bits once doesn't really have much of a performance impact. But if you were to iterate through like hundreds or thousands of pixels, then calling lock bits every time is redundant, and it will take a long time, which is why if you were to implement something like this using get and set pixel methods, without exaggeration, it could take like 20 seconds, whereas this will only take like a quarter of a second. Image lock mode, we're going to do read and write because we're going to be negating it, so we gotta see what the color is of the pixel. Then we're going to be setting it using a little calculation. Then our pixel format is the way that it's going to save the data. And you could theoretically use any of these, and you just have to write code to go along with it. But I'm going to be writing it for this. Now, be careful to do this and not make sure there's no p here, because if it's p, this is pre-multiplied, and that's different. That's a lot. Pre-multiplied is a lot harder to work with, and we're not going to be doing that. So at the very end here, we're going to be unlocking it like this. Now the next thing you gotta do is get a bunch of rectangles, because that's the easiest way to see what falls in this region. So we're going to be using a method called getRegionScans, and it takes a matrix. So we're just going to create a blank matrix for this, and we're going to pass in here, and then can't forget to dispose it at the end. So now that we've got everything locked and we have region scans, the next thing we're going to do is we're going to just add some stuff like this. We're going to put these here because it's going to be a lot easier to access them, because whenever you're accessing something like this, it's going to be doing a p invoke under the hood, which on a one-time thing really doesn't matter, but if you keep calling it, it's going to get a little slower than if we just did this. It'll speed it up probably won't really notice it, but it's better to do, and it's easier to type anyway, so why not? So I'm going to make another one for stride. And we're going to make one for bytes per pixel. Now, bytes per pixel is we're going to be using this method, and we're going to be passing in. That's the pre-multiplied. Don't use this. Remember, no p. And where's format 32 ARGB? That's what we're looking for. Here it is. So we're going to divide this by 8 because this is going to return bits, and we want it in bytes. So if you want to go from bits to bytes, you divide by 8. So now we are going to now all we have to do is loop through these rectangles. So we're going to do rectangle R in R's. I should call this RE. And we're going to make a new rectangle. This is going to be a rectangle F dot ceiling. Seal is that so rectangle that's okay, it's rectangle that's ceiling. And we're going to be passing this in, and it's going to create a rectangle out of a rectangle float. Because this is a rectangle float, this is going to turn into an rectangle, which is going to make it so we can just go through it. So, and I equals 0, or not, actually let's call this x equals r dot left, r x is less than r dot right, x plus plus, and then y equals r dot top, y is less than r dot bottom, and then y plus plus. So we're going to be looping through each coordinate that these rectangles contain in our region scans, which is a bunch of rectangles split out of this region. And for each of those, we're going to be creating our color. Or actually, okay, so now what we're going to do is we're going to get a pointer to the current pixel we are at, or the current pixel we're at, and it'll show all the channels. So what we're going to do is create a byte data here, but first I have to create our scan 0, and I'm going to do d.scan0, and this is going to return an input pointer, which is going to cast to a byte, and it's going to say it can only be used in unsafe context, and we're going to allow unsafe. Oh, it's not. I don't know why it's not popping up the little thing. And here it is. And then allow unsafe code, which is a setting which you can just go change, or you can just click that and it will allow unsafe code, because these are pointers to the actual memory. So this is the start. This is basically the first pixel address of the pixel data. So what we're going to do is scan 0. So this is our starting point. Scan 0 plus, and then we're going to do y times stride. Now y times stride is basically our how far we are down. Like, I think that would be called a row, or how far we are, basically like all these. A y times stride. A stride would be how the height of like this bar here, and then 2 would be this, 2 would be this, so it's how many rows down. And then x times bytes per pixel. This bytes per pixel is how many bytes are in one pixel, which will be made up of the channels. So after all 4 channels we have, how many bytes make that up would be times x. So for our first pixel it would be 0 times that, and then the next one would be 1, and it wouldn't just be 1 byte over, it would be however many bytes are in a pixel over, which is why that is. So adding all this together will give us our data, and this is the address of our pixel. And in this we can find the address of each of the things. So this first one, data 0, is actually our alpha, so we're not going to change it. Or I'm gonna I lied. So our first pixel here is actually our blue, not, this kind of lies to you. It says ARGB. Well, actually the order that colors are in this is BGRA. And so this first one is actually blue. But it doesn't actually matter, because for negating stuff, if you think about it, if you negate white and black, so black is 0, well 255 minus 0, that's white, and if you did white is 255, 255 minus 255, that would be 0, which is black. So, and you can check out that'll work for everything. So it's just 255 minus the color that's already there will give you the negated version of that color. So, cannot convert type into, oh, you need to gas this to a byte. And then we can do the same thing for the green and the red with this, and then data 3 here is alpha, which we're not going to do anything with. We're just going to leave it how it is, and that should be it. So we can run this and see if it works. I still have it called black and white. I misnamed the project when I was originally making it. So, if you click all, you can see negates the little thing, click revert, half. Now the interesting thing, if we hit circle, you can see that when you negate 2 things over again, it negates them back. So if you do this, you can keep messing around with this, and you can see you can get cool things with that, and you can see it works. Any region we want, it does it. So thank you for watching. As it says here, subscribe, like if it helped you, comment. If you're confused, there will be a paste bin in the description with all the code.